Right, so the last time we stopped here and wanted to continue with the explicit verbalization. Uh, we finished basically introduction to pointers, so also some analogies to pointers, how we handle pointers, and operations on pointers, assignment, accessing pointers, limited pointer arithmetic, and comparison of pointers. So the next topic, as I mentioned before, it's about verbalizing pointer operations. Here are they. So let's start. Here you see a table that shows everything. So let's turn now our attention to how to verbalize various aspects of pointers. If we can consistently and clearly talk about pointers to ourselves, then we'll have a firmer grasp on how they operate and what we are actually doing with them. Talking correctly leads us to think also very clearly. So again, here declare a pointer that would be with the syntax int star p dimension. P dimension is a pointer to an integer, how we say it. So p dimension is a pointer to an integer. Assign a named location to a pointer. You see that here, and p dimension has the address of height. P dimension points to the height, or height is the target of p dimension. Then again, access the target of a pointer through star pdim or p dimension. The value dereferenced by pdim, the target of pdim, the value of pdim points to, or the value of at pdim, and then assign a value to the location that pointer points to. The target of pdim is assigned a value of 10, or the value at pdim is 10. Access the value that the pointer points to. Width is assigned width is assigned the value of the target of pdim. Width is assigned the value at pdim, or pdim is dereferenced and assigned to width. Then compare pointers for equality. So if pdim equal to pdim2, so pdim1 to pdim2, so p dimension 1 and p dimension 2 have the same target, or pdim 1 and pdim2 point to the same address. So the question is, do they point to the same address? Now compare pointers for inequality. pdim and p1 and pdim2 have different targets, or point to different addresses. Compare targets of pointers. So if star pdim1 is equal to star pdim2, the target of pdim1 is equal to the target of pdim2. The reference value of pdim1 is equal to the reference value of pdim2, or the value at pdim1 equals the value at pdim2. Verbalizing each of these in this manner may take some practice or simply consistent repetition. So we have now covered the basic mechanisms of pointers, declaring them, assigning them, accessing them, comparing them, and even talking about them. We can continue now with variable function arguments. So as we saw in chapter 2, understanding program structure, function parameters in C are called by value. In other words, when a function is defined to take parameters, the values the function body receives through them are copies of the values given at the function call. The following code copies the values of two values into function parameters so that the function can use those values in its function body. Okay, let's see it. So in this example, the rect parameter function takes two parameters, h and w, and returns a value that is based on both of them. The parameter of the rectangle. When height and width are assigned to them so that h has a copy of the value of height and w has a copy of the value of width. In the function body, the values of h and w are modified and then used to calculate the returned value. When the function returns, h and w are deallocated or thrown away, but the values of height and width remain unchanged. This is how call by value works. One advantage of call by value is that we can modify the copies of values passed into the function and the original values remain unchanged. One disadvantage of call by value is that for parameters that are very large arrays or very large structures, this copying is significantly inefficient and may even cause the program to crash. But what if we wanted to change the values in the origin variables? So we could contrive a structure to hold all three values. As well as copying in and then copying them back to that structure. Let's read it here. This is it. So this would involve the following code: type, def, struct, rect, dimensions, and so on and so on. So that's quite cumbersome, and it's also unnecessary. There is a better way of doing this with pointers, which we will explore in the last section of this chapter. So using pointers to structures. Let's do now passing values by reference. If we wanted to change the values of parameters so that they are also changed after the function returns, we can use pointers to do so. We would assign the address of the values we want it to modify to pointer variables and then pass the pointer variables into the function. The addresses will be copied into the function body, and we can dereference them to get the values we want. This is called passing by reference. So we had until now call by value, and now we talk about passing by reference. So passing values by reference is the next topic. Let's see. If you wanted to change the values of parameters so that they are also changed after the function returns, we can use pointers to do so. We would assign the address of the values we want to modify to pointer variables and then pass that pointer variables into the function. The addresses will be copied into the function body, and we can dereference them to get the values we want. This is called passing by reference. So, just as mentioned before. Then let's do this direct parameter function takes now 2 pointers ph. Here we go. So ph and pw. When the function is called and the ph and the pw created and the values of p height and p width are assigned to each. ph has the same target as p height and pw has the same target as p width. To use the desired values, pointers are dereferenced and 10.0 is added to each. And then when the function call, so here is an example where star ph plus 10 is going to be there, and then shorthand comes handy recall the equivalent star ph equal to star ph plus 10.0. When the function call is complete, height now has the value 25 and the width has the value 32.5. You might want to verify this yourself with a similar program, but one that prints out the values of height and width both before and after the function call in the main. And a function that modifies values that exist outside of its function body is said to have a side effect. In this case, these side effects were intended. However, in many cases, side effects may cause unanticipated consequences and so should be employed with careful intention and caution. Now let's return to our earlier program that we looked at here recently that dealt with height, width, and length. Let's come here. This is it. So as you examine it, you might think that the printing part of the program is quite messy, and there might be a way to create a cleaner solution. We can create a function that takes 2 pointer parameters but doesn't have any side effects. Say the pointer's targets are not modified in the function body. So let's copy this time pointers 1c to pointers 2 file. Let's also save it, run it if it's necessary. So save as. Pointers to C file. And then add the following 2 functions. So after include stdio and before int main, void show info int height, int width, int length. Good. Then print. We can actually take this. Size of int is equal sign, then %2 long unsigned next line, size of int, that's exactly what we wanted. Okay, and then height width. So I'm going to take this one too with me to the top part. Now let's see, yeah, this is correct. Then let's see the next one too. Let's take a look. Here we have void show variable and car start PID, and let's do it. So again, void show variable and okay, so let's declare char as a, what exactly we need to do is, where is it again? Hold on a moment, please. So PID is a pointer to a character. To use the correct verbalization as well, so verbalize it correctly. And then pdim is a pointer to an integer. So int pdim. If I'm not wrong, obviously, if I'm not wrong. So let's see. Yes. Okay, good. Then let's continue with printf. Actually, I think we have this printf as well. Just let's do this. Okay, let's see address of %s percentage hash alex value at the address to okay, and then PID. Okay, let's do it. PID, then unsigned long, and pdim. Okay, should be all right. Okay, and then we change everything else as well. Let's see what we still do. Okay, here we go. So not sure if you have to still keep it or change it, but so let's see first. So the body should now look as follows. You see here. Let's take a view about it. Int height, width 4040, and here we go with int p dimension set to null, and char p identifier set to null. Okay, and then let's continue with printf. Yeah, let's do it. So new line values and new line. Good. Next print is show info. Height width length, then printf again, and this time address of p dimension, address of p dimension, so the pointer dimension of dimension shows the address LX, sharp LX, right? And a new line, and we got here not this but unsigned long, and amplifier p dimension, and close it. Good. Then the next printf we have is new line using address of each named variables okay. New line, and this part I don't need as well. And then the next printf we don't need. This is done now, I think, right? Yep. Okay, so now we go with p identifier, and oh, I need that, so p dimension I need, but I can copy this and rewrite it. So p identifier, and it's going to be height, then p dimension we have the amplifier height, then show variable p identifier and p dimension. Then we go with p identifier again, so we copy this, and this time I'm going to get rid of this part. So let's see, not height this time, it's going to be width, and amplifier width, then p identifier and p dimension, and we are good to go. The next one is, oops, so this time it's length, also here length, and p identifier and p dimension. So we move the message bits of printf into show info and show variable. Show info simply uses the call by value for each of the variables we want to show, and this is what we did before. The interesting part is making the two parameters to the show variable. Here you go. Pointers. One a pointer to char, so character data type, and the other pointer to integer data type. So the target of this will be the value of the variable itself. So at each call to show variable, we provide a pointer to the variable's identifier and the pointer to the variable's location. Let's try to save this and let's try to run this code this time. Okay, there is some kind of mistake here. Let's move up. I'm not sure if it is what the problem is. Unsigned long. Here we go, the address we forgot. So amplifier. Ma. Ma. Wait. So wait a second. Show variable, one more time. So show variable unsigned PDM. No, that's correct. And so it's not that. Once again, let's see. PID, right? Then unsigned long is also good, and PDIM. Dim. PDIM. And then PDIM. Okay. That works. There we go. Good. This is exactly what we wanted to have. You see, we basically got to the same values as before, so everything is correct. Okay, we can see both of the sizes of INT and the pointer to INT, as well as the values stored at the height, width, and the length named locations. Next, we see both the addresses of each variable. And to confirm the correctness of pointers, we can see the values stored at those addresses that correctly correlate to the values in our named variables. Note how each address is offset by 4 bytes. This, by no coincidence, is the size of INT integer. Okay, we can continue now with passing addresses to functions without pointer variables. So we can actually go one step further and remove the pointer variables in main function and then pass the desired addresses directly in each function call. We'll still need the pointer variables as function parameters in the function definition, just not inside the main function body. So let's copy pointers 2 to pointer 3 and then modify only the body of the main function as you see here. Okay, let's do it. So we are good to go again. Let's save it. Okay, and this time we change our main. So we take this out. Printf values and okay, cool. Show info. Oops, what did I? Good. Then we got all show info height, width, and length, and then printf address of the dimension we don't need, right? No, wait. Using address of each name variables. Yep, we don't need this part. Using address of each name variables. Okay. Then show variable p identifier. This one we take out again. Wait a second. Show variable. Height and height. Okay. So show variable. This one. With the positioning. Okay, this is now done. Then I can take this one here. Both we can delete. And length. And amplifier length for the p dimension. And both we can delete. So the show info and the show variable functions do not change. You also have to remove the printf statement that prints info about the p dimension. Is there any p dimension? Nothing. Yeah, nothing. Okay, good. Then you'll also have to remove the printf, then save and compile this time. Let's try it. Okay, now here we have a semicolon, but, and here we have exactly what we wanted and everything works correctly. Yeah. You may notice that the variable addresses have changed since we removed p dimension. Yeah, they changed. They definitely changed. No. I saw here some kind of 3C. I don't remember exactly. Anyway, so in this case, as you can see, they have not changed. Yeah, they have not changed. That's the truth. Okay, pointers is our next topic. We are very near to close our chapter as well. So if we can have a pointer that points to a variable, it should come as no surprise that we have a pointer that points to another pointer, which then points to our desired variable or variable. This is called a double indirection. When using a pointer to a pointer variable, we must doubly dereference our starting pointer to get the desired value. Why might we need to do so? Well, consider the following here. Now you might have observed that we didn't move this code snippet into the showInfo function. That is because if we passed the p dimension into the function as a parameter, a new temporary variable would be created and the value of p dimension variable would be copied into it. We would thus see the address of the function variable, which would be different from the location of p dimension. We can move it into the showInfo, but we will need to use a bit more trickery with pointers. To show the value of the pointer itself when we pass it into a function, we have to create a pointer to pointer. This is a pointer to a named location, or more precisely, it is a pointer variable that points to another pointer variable that points to the variable. So again, it is a pointer variable that points to another pointer that points to the variable or to a variable. Since this is somewhat advanced topic, rather than going into more detail, just let's see an example. So change how showInfo is called from main function. Your modification to showInfo should look as follows. So now we get into pointers 2 again. And copy pointers 2 into pointers 3, 4. That is the task this time. pointers for. Okay, then change the show info function. Okay. Your modification to show info should look as follows. Okay, so print f size int percentage. Okay, cool. And print of height width and Alex, right? Oops. Wait. So yeah, okay. So we got one more printf here. So one more time. Exactly. Address of p dimension is percentage hash Alex and new line. And then unsigned long ppdim. Cool. Now change how show info is called from main. Remove the printf statement for p dimension in main. Okay, we need to get rid of this here. Wait. The first one is okay. P dimension null, PP dimension. Okay, we got here P identifier, and we got here one more int, 2 stars, and PP dimension, which is having the address of P dimension. And a null. Cool. And then this time the printf, this is all right. Then show info is height with length and pp dimension. And then here, I think this is what we need to get rid of because we have just done it. Okay. Then so height, and then using address of each named variables. Exactly, good. And then remain this way. Okay, anything else we need to consider to change? Then let's see it. Okay, cool. Let's try to run it if it is possible. So save and compile. Let's try to run it. Okay, we got here some kind of issues. Show info too many arguments. Here. This is not added yet. Let's take a look. INT star star and ppdim. Yeah, we got it exactly how we want it. Oh, and you see also the addresses are changed. Remember 40 and 44 we had, or 44 and 48 and 4C, and now it's changed as well. Again, new call, so addresses might change. Okay, so this is also done. And using pointers to structures is our last topic in this section or in this chapter. So before we finish with pointers, we need to expand the concept of a pointer pointing to a variable of an intrinsic type that of a pointer pointing to a structure. We can then also expand typedef specifiers to structures to include typedef defined pointers to structures. Recall that the pointer points to the first byte of a target data type. So also recall that a structure is a named location that holds a collection of named values. A structure as a whole is named, as are each of the member elements of that structure. Once the structure type is defined, variables may be declared that are of the type. When a variable of any type is declared, the appropriate number of bytes are allocated in memory to store the values of that type. We can then access the member structure elements directly through the structure variable's name and the dot notation. Declaring a pointer to a structure variable is no different than declaring a pointer to any other variable. So that variable must already have been declared that is allocated. The pointer address is the first byte allocated to the structure, just as for any other variable. So for this exploration, we use the date structure type, representing a numerical day, month, and year as defined. So we see it here. And then we can then declare the variables of the data of the type of follows, like so date, anniversary, anniversary month, anniversary day, anniversary year. Now we can declare a pointer to the structure variable as follows. So date star p anniversary with the address anniversary. So amplifier anniversary. At this point, p anniversary points to the structure variable as a whole, very much like other variables. Unlike intrinsic variable, we are not just interested in the structure as a whole, we are more interested in each of the structure variables elements. So we can also access structures and their elements through pointers. We access the structure as a whole as we did with intrinsic variables, so that p is a star p anniversary, or a pointer that points to the anniversary, right? Same memory location as we know. So to access one of the anniversary elements through a pointer, we might consider using p anniversary dot month. However, because of the dot operator has a higher precedence than the star operator, the element reference will fail evaluation and will be inaccessible. We can change the evaluation order with parentheses, and that's what we should also do. You see it here as follows. Or there is another way. As an alternative solution, so alternative syntax to access structure elements through pointers is with an arrow. So the alternative syntax uses 2 fewer characters, a slight improvement. Whether you find one method easier to read and the other, the general advice is to pick one and use it consistently. Almost done. So using pointers to structures in functions, we can do indirect reference to a structure variable as easily as we can do a direct, so variable identifier to a structure variable. We can use the indirect reference in function parameters to avoid the unnecessary copying of structures to temporary function variables. We can use the structure pointer in function parameters as follows. You see here, void print date star pdate. We declare at the pointer to the structure type in function declaration, and then we define the function accessing each element as follows. So in the definition of print date, we can use the different dereferenced pointer values without creating and assigning temporary variables. We would call then the print date as follows. Yeah, here we go. And we could then construct the entire file as well. So I got everything together now. I added the type def struct, int date, month and year. Then here we go with the function prototype. And then we started to build the function. So int m and day and year. So p date, date, the month, and so on and so on. And 4224. So here it's the same. I mean, these two are actually the same. So either I use this part, right? Well, I'm going to use this part. So let's try to run it first, and then we see the results as well. Then in the main, I added this here, what we also had in our file, right? See this one. So again, we can then see what the results are, and then the return is 0. So let's see what we got here. So you see the dates are here. What if I just get rid of, let's say, this part this time? And I'm going to check the pointer-to-pointer version. And then again, here again, so this I need. I don't need, I guess. No, I need because of the selection. Good. Then yeah, I think I don't need this one here, right? Now let's try to run it. And here we go. We have everything correctly. That's it. So exactly what I expected. It works fine. So we basically finished with the remaining part. I don't look at now because it's something that we don't have here. But the point is that we finished with our pointers, and that's very, very cool. We just finished with that. So in this chapter, we learned how pointer is a variable that points to references, value, so points to or references a value at a named location. To use a pointer, we have learned that we must know either through a definition or through casting the type of the pointer's target, as well as the address of the target. Pointers should always be initialized to a named location or set to null. We have explored the relatively few operations on pointers, so assignment, access, dereference, and comparison. We have also extended the idea of pointers to variables to include pointer structures and their elements. We have also seen how we can use pointers to provide greater flexibility in passing and manipulating function parameters. That's it. So this chapter is actually essential to understand the next chapter, understanding arrays and pointers, where we will extend our concepts of using pointers to arrays. We will see how to access and traverse arrays with pointers, and remember that an array is also a named location that holds a collection of unnamed values, all of the same type. The array as a whole has an identifier, but each of its elements are unnamed. They are relative to the array's name plus an offset. As we will see, these array concepts dovetail nicely with and extend our existing concept of pointers. And now I would like to say, this is a long video, I know, but I'm still happy that you continued watching it, and I would like to say really thank you very much. And I hope that this video was good enough to start with pointers, and please take some more examples for your studies to understand better pointers. Me too, I'm going to do that with you if you want, but I do it by myself as well. So once again, I would like to say thank you very much and have a wonderful time. Bye.